All right. Hi, everyone. I'm going to do this question on inheritance. I'll just read it out. Experiments were conducted to obtain data on the traits seed shape in plants and feather color in chickens. In each case, the original parents were pure breeding and produced the first generation. The data diagrams below relate to the second generation offspring produced, F2, when F1 generations were bred together. Okay, so there's a few hints there already, right? F1 were the result of pure breeding, and then that gives us F2, right? So let's get started, right? So to figure out what happens in F2, we have to know what happens in F1, right? So I'll do it on the board actually. I'll do it separately for seed shape and for feather color. We can see that the ratio is different. So for seed shape, we have a ratio of 3 to 1, right, for our phenotype. And for feather color, we have a ratio of 1 to 2 to 1. Yeah? Make sense so far? Cool. All right, so let's look at F1, right? The original parents were pure breeding. So what pure breeding means is they're homozygous for whatever trait they have, right? So in this case, well, let's just assume because we've got a mix already, right? They have to be pure breeding for a particular letter. Seed shape, I'm going to assume that means like, I don't know, like wrinkled or not wrinkled, but I don't want to use W. Can someone suggest me a letter to use? Huh? R? Okay, yeah, I'll use R, right? So big R, and little r, right? So obviously the reason why I've used uppercase and lowercase is because we've gotten a different ratio in the F2 generation, right? So if everything was capital, it would always be capital R no matter what, right? Even in F2. So that's why, because I got something different, because it's not a 4 to 0 ratio, that tells me that the pure breeding parents that made F1 were probably homozygous, but there were different types of homozygous, right? So homozygous dominant and homozygous recessive, right? I then fill out my table and I get all heterozygous combinations, right? This is my F1. Right? Then the question says, we have to then cross them again. They get bred together to make my F2 generation, right? So my F2 generation, which I'll write here, is just a heterozygous cross, right? All right, cool. So can we see here in this Punnett square that now my genotypic ratio is 1 to 2 to 1, right? My genotypes, right? Because 1 big R, 2 big R, little r, and 1 little r. But my phenotypic ratio, right, is 3 to 1, right? Or can be 3 to 1, which will match my seed shape because 3 of these have a capital R. So I'm going to assume that the pattern of inheritance in this case is a simple monohybrid complete dominant situation, right? Where the capital R will fully express itself over the recessive, right? So that is one pattern, right? That's for graph A on seed shape, right? I'll just write complete dominance. Right? Now, I'll do the same thing for this one, but we notice that our ratio is different, right? It's 1 to 2 to 1, which tells me, okay, it can't be complete dominance. It has to be something else, right? So I'm immediately thinking, okay, it could be, multiple alleles. It could be codominance. It could be incomplete dominance, right? Well, we'll figure that out, right? So feather color. Again, we have 2 original parents that are pure breeding, right? And then they make the first generation. So again, because the ratios are split, I'm going to assume that the pure breeding parents were still homozygous, but they were different types of homozygous, right? So I'll just use, let's just use blue and red, right? So I'm going to assume that one parent is blue and the other parent is red, right? I cross these two pure breedings together, and that gets me a heterozygous set of combinations. And this is my F1, right? Same thing, right? F1 generations get bred together, which will then make my F2. So I have to breed two of these heterozygous pairs together. Right? So BR, BR, right? Cool. So looking here, right? My genotypic ratio is 1 to 2 to 1, but my phenotypic ratio can also be 1 to 2 to 1 if, say, we saw like maybe codominance, right, being observed, right? So we know that in codominance, both traits are expressed, which would then give you a distinct phenotype, right, which could then give you that 1 to 2 to 1 ratio. So let's say that maybe B is blue, R is red, and then BR is blue and red, right? So in this case, for my capital Bs, my homozygous ones, that would be a blue, what is it? A blue bird, right? A blue bird. Double R, that's a red bird, and blue and red, that's a bird that has both blue and red colors, right? In that instance, I'm getting the same ratio, right? 1 to 2 to 1. Does that make sense? Yeah? Now, it's a 5 marker, right? And the question says, explain the phenotypic ratios in both the plant and chicken breeding experiments, include Punnett squares and a key to support your answer. So what do you need to get 5 marks? Well, you should probably have this ratio in your answer. You need to show your Punnett squares as well, right? You could probably get away with just showing your F2 Punnett squares that lead directly into the ratio, but you should write at least the F1 genotypes that you're putting in, right? So that you can like show the marker. You didn't just stumble upon the correct answer, right? And you also need a key, right? So a key is just, well, actually, I didn't have a key here. It's not good, right? So I'll add my key, right? So B is blue, R is red, and same thing for here, seed shape. R can be round, right? So big R is round, and then little r, let's just say it's not round. What's not round? I don't know, square shaped, whatever. Let's pretend it's a magical land with square shaped peas. Cool. So in my response, right, I need to include all this, right? So this is like the raw data I need to have. And then I'll probably just write some explanations around it, right? So some of my reasoning behind why I picked this, right? So I could say something a bit like, I'll just do A first. So for A, the ratio is 3 to 1. I mentioned phenotypic. This is typical, or this is expected for complete dominance, or a pattern of complete dominance. Complete dominance. Right, then I might say the pure breeding parents are homozygous. Then I can just start including my info, right? So I'll say, what do I use? I use R, right? So capital R, and lowercase r. Then I can say this when crossed to produce an F1 gen, I would get it produces all big R, little r, or heterozygous combinations. Right? Now, it says include Punnett squares, so I probably should also include a Punnett square for this first one, this first cross as well. I won't do that because I've already done it on the board, but just for the sake of just writing it down, I'll write down the F2 cross, right? When bred for the F2 gen, I'll do my cross, so big R, little r, big R, little r. Right? I might say since capital R is dominant, 3 out of 4 options will be, I should assign this actually. So I'll assign my capitals as round, and what did I say for not round? I said square. Okay, sure, square. Right, will be round, and 1 out of 4 will be square. And then I can just conclude by saying this reflects the 3:1 ratio. Right? So in my answer, right, I've talked about the trait, I've identified the pattern of inheritance, right, in this Punnett square, which is complete dominance. I've referred to my ratio, I've mapped out on a Punnett square how I actually got that ratio. So, you know, the marker knows I know what I'm talking about. I've added a key, right? I've assigned genotypes for parent, and then I've given the phenotypic ratio again and linked it back to my explanation. Now, you have to do this twice, right? Because I just did this for graph A, right? You got to do this whole same thing again and repeat it for graph B, but using this set of data instead, right? And if you did all that, you should get 5 marks.